So here we're supposed to find the value of x. And so we need to set up an equation. And there's actually a relationship. If you have interior angles and they are remote, that means that they are away from the exterior angle. We learned a theorem that says to find the exterior angle that's equal to the sum of the two remote interior. In other words, I am going to do my equation as x minus 16 plus x plus 3 equals x plus 42. Oops, this should be equals. So x minus 16 plus x plus 3 equals x plus 42. And then from there, you just do algebra. So you look on the left, you say, okay, that's 2 x's. Negative 16 plus 3 is negative 13. Subtract x from both sides. Add 13. And I get x is 55. Now you might be thinking, how do I know if I'm right or wrong? Well, there's an easy way to check. What we could do, and they didn't tell us to, but if I'm taking an important test, I would definitely check my answer. I'm going to plug in and see what these angles are. So if I plug 55 here, I'd get 55 plus 42. That'd be 97. So this is 97 degrees. If I took 55 here, 55 minus 16 . 55 minus 16 is 39 degrees. 55 plus 3 is 58. And then we're just going to confirm that 39 plus 58 equals 97. And if you type this in your calculator, you do get 97, because the sum of the two remote interior angles is equal to the exterior angle. Okay, if you're at home watching this, number 2 is just like it. I would encourage you to hit pause and try number 2, see what you get, and then play the video again to see if you got the right answer. So the next problem, to find the exterior angle, which is x, it's on the outside, that's why it's called exterior. You add up the two interior angles that are furthest away. We call those remote. So this one is remote interior, this is remote interior. So if you take x minus 19 plus x minus 26, you get x. So we're going to set up our equation. And then from there it's algebra. So on the left I have x and x makes 2x. Negative 19 and 26 would be negative negative 45. And then from there there's multiple ways to get to the answer. The thing I saw most students doing so far is they subtracted x. And 2x minus 1x is just 1x. Because you have nothing left over there, that's 0. And then you could add 45 to both sides. And you get x is 45. Now, probably an easier way is at this step you could have done minus 2x from both sides. And then you'd have 1 minus negative 2, which is negative 1. And then divide both sides by negative 1, and you would still get 45. So there's multiple ways to get to the answer. Now, am I right or wrong? Again, it doesn't hurt to plug in. So x is 45. What's 45 minus 26? That's 19. And then what's 45 minus 19? That's 26. Is 26 plus 19 equal to 45? Yes. So I know I did this correct. If this was a multiple choice test, I could also plug in the answers until I found the one that was true. Number 6, solve for x and y. These are what we call isosceles triangles. And how do we know they're isosceles? Because this marking says that this side equals this side. That makes it isosceles. Okay? This side equals this side. That makes it isosceles. Now, what's special about an isosceles triangle is that whatever sides are congruent, so this side is congruent to this side, that means that the angles opposite the sides congruent are also congruent. So what that means is that x, and we call these base angles, x equals 46. Okay, so in isosceles you will always have two angles that are the same. And so then to find y, what's left over, so I'd say y is equal to 180, because three angles in a triangle add up to 180, minus 46 twice. And if I do 180 minus 46, minus 46, I get 88. So I have my 88. Okay. So anytime you're confused, this is called your vertex angle. And then these are called your base angles. And so the base angles are always congruent. Are they always the ones at the bottom? No. They're not always the ones at the bottom, because you could take a triangle and rotate it. So it could be on the top, it could be on the side. So like this triangle has been rotated. And so this is isosceles, so the side across, the angle across from the sides are congruent. So let me think, these have to be the same. But I know this is 40 degrees. But I know all three angles add up to 180. So I could just take 180 minus 40, see what that is. And that's 140 degrees left over. So if I take off 40 degrees, that's 140 degrees left over. These must be the same. So then just divide that by 2, and you get this is 70, and that's 70. So I'd say x is 70, y is 70. And that's it. Draw two triangles below. Mark each with enough information to prove they are congruent, and then state which congruency theorem makes those congruent. So you're going to try to draw two triangles that look alike. Are they congruent? I mean, I did the best I could, but they don't look exactly the same. And so I'm going to decide which theorem I want to use. So they say mark each. So let's do side is congruent to side. And then I think the easiest one is just side, side, side. So let's let this side equal this side. That's another S. And then let's let this side equal this side. So which congruency theorem makes these congruent would be S, S, S. So by the SSS, we know these triangles are congruent, which also makes the angles congruent. So if this is 30 degrees, that's 30. If that's 40, that's 40. Because by using the SSS, side, 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 that shows congruency. Alright, so which theorem or postulate proves the triangle is congruent? Remember, the possible theorems and postulates that we could pick from are SSS, SAS, ASS, which actually does not work, and it's easy to remember. Most people put that as SSA. That's just that spelled backwards. That doesn't work either. Another combination of SSS and S with S and A would be AAS, which is the same thing as SAA. And then angle, angle, angle also doesn't work. And then there's also one called hypotenuse leg if you have a right triangle, which, looking here, I don't see any square to show that they're 90 degrees. So I'm not going to use HL on any of these. And then another one is angle, side, angle. So let's go through these, and we're just going to do one thing at a time. I'm going to do step one. Which theorem proves the triangle is congruent? So let's go through. I know that this side equals this side. So I'm going to put an S. I also know that this side equals this side because of the marking. So I'm going to put an S. And then furthermore, I know that this angle equals this angle. And how do I know they're congruent? Because they're vertical angles. Vertical angles are congruent. So now I got A. Now, when you're naming these, obviously it's going to have two S's and an A, but the order matters. You're not going to call this SAS. You don't take the long way. You always take the short way. So when I'm looking at this, this would be SSA. Which actually SSA, if you look up here, does not prove congruency. So I would say for number one, I would say which theorem or postulate proves the triangle is congruent? We don't know if they are congruent. We can't prove that. And the reason why we can't prove congruency is because the SSA one, which is easy to remember if you spell that backwards, it's called the donkey theorem. It doesn't work. It does not show congruency. That's why I crossed it off. Select the rigid transformation that has been used. Assuming that they were congruent, really step 2 and 3 make no sense if they're not congruent. But to get from here to here, so the words you're going to be using for transformations, that could be translate. That means when you move it. So when you move it, it stays the same, it just moves. You could use the word rotate. That's when you turn it. And then another word you could use is reflect. And so when I look at this, it looks like this is just turned. So I would call this a rotation. It can't be a reflection because if you reflected it, then this side and this side would need to be the same, and they're not. And then write the congruency statement. There is no congruency statement. So now would be a good time to try number 25, see how you do. You can hit pause on the video and check your answer. Number 25. I know that this angle equals this angle. So there's my A. A stands for angle. I know that this side is congruent to this side. That's where the S stands for side. Furthermore, I know that this angle equals this angle because they're vertical angles. There's my other A. Now, order does matter. You're going to go in the smallest possible way. So I would call this. So looking at this, I would call this AS. Now you might be thinking, why is it not ASA? And it's not ASA because when we filled out our notes, in order for it to be angle side angle, the side has to be between the two angles. So had it been this side, which is between the two angles, then it would be ASA. So this one is actually AAS, which is a theorem, AAS, or postulate. 2, select the rigid motion. This is not reflected. If it was reflected, then this side would equal this side. It's actually turned. If you turn this, you get this. So I'd say rotation. And by the AAS, we know that this triangle is congruent to this triangle. Now this is very important, and you may not fully understand this part, but you're going to say triangle something with 3 letters is congruent to triangle something with 3 letters. And the letter you start with doesn't matter, but the order does matter. So let's say I decided to start at A, which is this A. Not to be confused with A, the angle. So if I start at A, then when I write my congruency statement, I have to make sure on the second triangle that it's in the same spot. So if I start A, I need to start with E. Why? Because those angles are congruent. So this has to be triangle E. And then it's really your choice. Do you want to go ABC or do you want to go ACB? It's your choice. So let's say we call this triangle ABC. Now the order here would matter. If you go this way, you need to go that way on the other one. You cannot go E, C, D. The C should be in the same spot. So if the C's here, the C should be last here. So it'll be E, D, C. And the reason why that's important is because now we know angle A equals angle E. We know that angle C is equal to angle C, which obviously. And then we know that angle B is equal to angle D. So the way you write these letters do matter. Number 12. I have S. I have S. The oranges are congruent, the blues are congruent. And then I also know, and this is by the reflexive property, that HP equals HP. If they share the same side, then of course they're congruent. So when they say what theorem or postulate, this one's easy. It's SSS. 2, what rigid transformation is this? It can't be a translation because it wouldn't have turned or anything. And it's not a rotation because then this would be over here. So it's actually reflected. This is flipped over. So the triangle on top is flipped over this line, making this and this the same. So this is a reflection. And then my congruency statement. Let's say I call the first triangle HOP. That is congruent to triangle. So I would obviously start at H again to say that H equals H. H. So I want HO, so I need to go HE. HEP. Notice the H's are in the same place, the P's are in the same place. That is important. Next, anytime you see this symbol with the double arrow, sometimes it's just one arrow, that means parallel. When you know things are parallel, you can use all kinds of different postulates and theorems. You could use the corresponding angles postulate, you could use the alternate exterior angle theorem, or interior. You could use consecutive interior. So you can only use those if you have two parallel lines cut by a transversal. Now you may not be seeing this, and sometimes it's good to go ahead and recognize that this line is parallel to this line. How do I know that? By the symbol. And then this would be the transversal. And so we know that this angle is congruent to this angle. And we would only know that because they're two parallel lines cut by a transversal. And if I had to do a proof, I would say we know those are congruent because they are alternate interior angles. So there's my A. I also have S, because I know this is congruent. And then, because of vertical angles, I know that this is congruent to this. So we know it's going to have an A and an S and an A. The order does matter. Just try not to go the long way. Like you wouldn't call this AAS, because that would be the long way. You'd call it ASA. ASA is when the side is between the two angles. What's the rigid transformation? Looks like it is a rotation. This one is turned to get this one. And then write the congruency statement. I'll say triangle ABC is congruent to triangle. I know C is going to be the last one. Let's see, I want A, B, C. So I need to go D, E, C.